Hello Internet, welcome to another tutorial in information theory and coding. In today's tutorial we'll talk about cyclic codes. This is an introduction to cyclic codes. What are their properties, what is the definition of cyclic codes. Please understand, cyclic codes are codes with some amount of information contained in them. So in other words, cyclic codes contains messages plus parity, so that when these kind of codes are received at the receiver, we are able to figure out is there an error, or if there is one, we can perhaps correct it. So as a matter of fact, cyclic codes are subclass of linear block codes. This will be the first thing that we would wish to remember. And according to the definition of cyclic codes, it's a code which is linear in nature. So the first thing also defines that it's a subclass of linear block code. So this code should be linear. And the second property, the code will be cyclic if it satisfies the cyclic property. We'll discuss both these properties in detail now. Linearity property is that property of the code which states that the sum of two code words should also produce a valid code word, right? And the cyclic property is that property of the code which says that if we shift a code word by one position, it should result in the formation of another valid code word. And we'll check that with the examples here. So I have got two examples. We have a set of code words here, and we need to check if the following code words are cyclic or not. So these codes will be cyclic if they'll follow these two properties. For example, if we add up two of these numbers, they'll result in a valid code word. So if we add up, let us say these, they'll also result in a code word which is there in the set. And similarly, if we add these two, it'll give me a code which is there in the set of cyclic codes. So property number one is satisfied for this set of codes. Now let's check the property number two, which is the cyclic property. Now if I was to shift this code by one position, I'll get this code itself. If I was to shift this code by one position, I'll get this code itself. So these two satisfy the cyclic property, but if I was to shift this code, it will give me this one. I shift this to right by one position, so this one goes here, and the 0 goes here, 1 goes here, 0 goes here, and this one goes here. So 1010 again is present as a code in this set. So this set of codes is cyclic in nature because it satisfies both the properties. On the other hand, if we look at this, we know that this and this are going to satisfy the shifting property, and again these two will also satisfy the linearity, because if we add these two, we'll get 1111, which is a valid code word in this set. But if we were to add this and this, we'll get this. XORing will get me this, and if we were to add this and this, we'll get this. So linearity is not a problem with this set of code words. However, if we apply the property number 2, and if I shift this with 1 bit, I get 0011, and it is not a key code word in this set. So this code x2 is not a cyclic code. And similarly 1011 again, 1001, I'm sorry, if shifted by one place will give me 1100, which again is not a code word. So in order to be cyclic, a code should satisfy both properties at the same time. So this is not an or kind of a situation. So both the properties must be met in order to be a code to be cyclic. And I hope this introduction to cyclic codes and its properties was of help. And if you liked the content, please share the content, give it a thumbs up, consider subscribing to the channel. I'll see you in the next video. Take care. Bye bye.